All right, we have which requires the most electrical power during operation. So with this problem, you should hopefully start to recognize what it's asking for is power, right? So it says power. So when you hear power, you should be thinking of the unit of watt. So we have our two equations that we're going to be using extensively through the electrical section. So we have ear and we have pi, right? So you can use the triangle method if you'd like. I have it above the equation. So whenever you have E is voltage, E stands for electromotive force. It could be potential difference. It's a difference in potential, a difference in voltage between 2 points, right? That's what it essentially is. We have current is in amps, and that's I. R is resistance in ohms. P is power, so that's the key word. We should have read that problem. We should have seen power, and we should be thinking watt, right? We're looking for the watt. Then we have I is current, E is voltage. So ear and pi, those are the two equations you need to be familiar with. Perfect. So let's look at it. So we have three different scenarios. Right here we have A. We have a 24-volt motor requires 3 amps. So let's look over here. So we have our motor right here. It's an electric motor. And we know that there's 3 amps running through the wire. So this motor is an electric motor, right? It's hooked to a 24-volt source. And that's what's powering this motor. This one's not talking about the motor efficiency or anything. So we know that this 24 volts battery is connected to this motor, which turns the motor shaft, and it takes 3 amps to do that. So again, we're probably going to be using pi most of the time in this equation, right? Pi. So we're looking for power because we want power in watts. Do we have the current? Check. Do we have the voltage? Check. So I is equal to 3 amps. E is equal to 24 volts. So all we have to do is plug in I and plug in E and multiply those two things together, right? So we'd have P equals 24 times 3. So P is going to be equal to 72 watts. So far, A is 72 watts. We're looking for which one, A, B, or C, requires the most power. All right, then we're at B. So it says 420-watt lamps in a 12-volt parallel circuit. So I just drew the parallel circuit. So with the parallel circuit, you're going to have where one wire is going to branch into 2 wires. That's how you can recognize a parallel circuit. We haven't talked about it. We're going to talk about it later. But so if you see a parallel circuit, it's going to branch. There's going to be 1 wire come in, 2 wires come out, or 2 wires come in and 1 wire come out. With a series, it's only one path. So here's parallel regardless of that. Okay, so again, we're talking about voltage. This is the symbol for a battery. The short side of the battery is the negative, the long side is a positive. So right here, the battery is 24 volts. The positive side of the battery means it's 24 volts on the top side, the top end of the battery, and it's 0 volts on the negative terminal of the battery. So right here, if I put my multimeter in this black spot and black spot right here, what I would read on my multimeter would be 24 volts. I would need to make sure that my multimeter is attached or is configured in the DC configuration. Let's say I took my multimeter and I put it on this side of the battery and I put it right there, this two spots. Well, what we need to know is that we're going to get the full voltage drop. So it's going to be 24 volts all the way from here for a parallel circuit, and it's going to be 0 volts down here. So we get the full voltage drop across every branch of a parallel circuit. So if I put my multimeter in these two spots here, here, and here, my multimeter will read 0 volts because there's 0 volt difference between these 2 points. Again, if I then put my multimeter here and here, my multimeter will read 24 volts because there's 0 volts down here, and 24 volts up here. All right, perfect. But anyways, this actually B is a little simpler than that. We didn't have to know, we did need to know about a parallel circuit and all that, but each one of these lights is 20 watts. So this one's already, it's giving us the power. We didn't have to do anything. It says, hey, this light's 20 watts, this light's 20 watts, this light's 20 watts, and this light's 20 watts. Therefore, to run every one of those lights, I have 20 times 4, which is 80 watts. So perfect. So we recognize, hey, we see watt. They already gave us the power, right? Okay, so then we have scenario 3. We have 2 lights requiring 6 amps, 24 volt system. So again, these are in parallel, right? So if I took my multimeter and I put my voltage one side of my multimeter here, one side here, I should be able to, my multimeter would read 24 volts, right? If I put my multimeter here and here, my multimeter should read 0 volts. Again, this is the 24 volt side of the battery. This is the 0 volt side of the battery. Everything up here is going to be 24 volts. Everything down here is going to be 0 volts. Okay, so let me get some of that out of the way. So we have our circuit, and we do know that each one of these lights has 6 amps running through the light. We also know the voltage drop. Do we know the voltage drop from here to here? We do. It's 24 because it's in parallel. So we're going to use our equation, pi, right? So we're looking for power. We want current and we want voltage. Or we need current and we need voltage. We want the power, right? Do we have both of those items? Yes. We know that the current is 6 amps and we know that the voltage is 24 volt drop across this light. I just represented the light as resistors and the same as on the other circuit. So we're just going to plug that into our equation. So we're going to say pi is equal to, it's actually going to be 6 times 24. Over here, I did just switch these backwards by accident, but it's not a big deal. 6 times 24 is going to be 144. So we have to make sure we know, hey, that's actually only for a single light. We have 2 lights here, so we need to multiply that by 2, and we'll get 288 watts. So the one that has the most power used or consumed is going to be scenario C.